In this lesson, we will define terms and apply facts concerning tangent lines and circles. The first term we need to know is the term common tangent. So we have what we call a common internal tangent, and then we have also a common external tangent. What that means is that if you had two circles, then a common tangent would be a tangent line that is shared with both circles. So we see here that segment RS and segment TU both are common tangents because they're both tangent lines to both circles. And the word internal means that they're going to cut through and cross over each other. So they're cutting in between the two circles and they're crossing over here at point Z. And then we have common external tangents. So a picture of that would look like this, where we have two common tangents because they're shared with both circles. And external means that they're not going to cross over each other. They're going to stay on the outside of the circles. So notice the segment does not intersect with the other segment like it did for the common internal tangent. So common external tangent, here we would have RU and TS both being common external tangents. Now we also have tangent circles. So the word tangent just simply means touching. And so tangent circles are circles that are touching at only one point. So here we have internally tangent circles where the one circle is inside of the other circle. And they're touching right here at this point. And then we have what we call externally tangent circles. So tangent circles, meaning they touch at one point, and that point would be right here. And then externally tangent means that they're touching on the outside. So the word external means outside, and these circles are outside of each other. They're not on the inside, they're on the outside. Next, we have a theorem. And this theorem says that if a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So to illustrate, here we have a circle, and we have a tangent line drawn to the circle. If we were to draw a radius from the center to that point of tangency, then we have a right angle. It's going to be perpendicular. And it does not matter where the tangent line is. The tangent line can be anywhere on the circle, and if we draw a radius to that point of tangency, it will always be perpendicular. So we see here, if I were to rotate the radius and the tangent line, they will still be 90 degrees no matter which direction I take the tangent line. And this is a theorem, which means that it needs to be proven. However, in this video, I'm not going to get into the proof as to why the tangent line will be perpendicular to the radius. So let's move on to the next point. Next, we have a corollary that says that the tangents to a circle from a point are congruent. So our point S is a point that we are referring to, and if we were to draw tangent lines from S to the top of the circle and the bottom of the circle, these tangent lines, these segments, we should say, would be congruent. And we will take the time just briefly to explain why this is the case, because based off the last theorem, if you have your center point right here and were to draw a radius up to this point of tangency, the theorem says that we have a right angle. And do the same thing down here to point T, here we have a right angle as well. So we have two right angles, and then if you were to draw a line going from the center to point S, that line segment is being shared with the two triangles that we've just now created. So that side would be congruent to itself, and because it's being shared by both sides, we actually have one side of the top triangle that is congruent now with one side of the bottom triangle. And then we have the segment going from the center to point R and the segment going from the center to point T. Those segments will be the same length because they are both radii of the circle. So R to the center would be the same length as from T to the center. So looking at the two right triangles that we have, the top right triangle has a hypotenuse right here that is congruent with the hypotenuse of the bottom triangle. So this segment here that's being shared is the hypotenuse for both triangles. And then the other segment from R to the center and from T to the center is a leg. So we have a hypotenuse and a leg that are congruent to another hypotenuse and a leg. So therefore, based off our hypotenuse-leg theorem, we have congruent triangles. And because the triangles are congruent, then therefore SR and ST would be congruent as well. So that is the reasoning behind this corollary. So in this example, if SR were 5 inches, then we know that ST would have to be 5 inches as well. And that concludes our lesson for today. We will see you next time.